Hi friends, today we are going to discuss the topic liquid state. In that we will see the property of liquid, that is surface tension, for FYBSc chemistry student. Myself Ramdas Suralkar, Assistant Professor, Department of Chemistry, Pratap College Amarner. The content of this topic are surface tension, capillary action, meniscus, cohesive and adhesive forces, determination of surface tension by capillary rise method and by drop formation method. Then we will see some problems related with this surface tension property of liquid, and then lastly the summary of the topic. Then we will see introduction to liquid state. So molecule in gases and molecule in liquid behave differently. Molecules in gases, they have large intermolecular distances between them, negligible attractive forces and continuous random motion. While the molecules in the liquids, they are close together, they have significant attractive forces, and also they are also in a random motion, continuous random motion. Temporary cluster form, leaving empty spaces or holes in the liquid. What is the definition of liquid? A liquid is a collection of molecules held together by together executing the random motions through intervening spaces. What are the physical properties of liquid? Physical properties of liquid mainly depends on the strength of intermolecular attractive forces between the liquid molecules. Two important properties we are going to discuss through this liquid state chapter, that is surface tension and viscosity. But in this video we are only going to discuss the first property, that is surface tension of the liquid. So what is meant by surface tension? So for this surface tension concept, we have to consider the two molecules in the on the surface of the liquid. One is at the surface of the liquid and another molecule is at the interior of the liquid. So the molecule which is present at the interior of the liquid, it is uh, attracted attracted equally from all the sides. Therefore there is no exert any force of attraction on this molecule. So the force of attraction exerted by this molecule from surrounding molecule is zero. So net inward pull is zero. But when we consider the molecule which is at surface of the molecule, then the surface molecule is attracted from downward side. So means it is attracted downward side, then there is no opposite molecule in the air for the attraction. So this molecule experiences a inward pull on this molecule. So surface tension arises from the intermolecular forces of attraction in a liquid. Interior molecule attracted equally in all direction by neighbors, because if this consider we interior molecule, then if it is attracted by surrounding molecule from upper side, equal and opposite direction, the forces also this molecule is also attracted from the downward side. So there is a force of resultant force of attraction on exert on by this molecule will be nil or zero. Similarly, if we consider it is attracted from right side, similarly, it is also attracted equally attracted from the left side. So resultant pull on this molecule is zero. So interior molecule, there is no resultant pull on this molecule. Therefore, it exists. There is no force of attraction exerted by this molecule. While surface molecule pulled mainly sideways and inward, giving a net inward force. So it experiences a net inward force. This inward pull makes the liquid surface behave like a stretch membrane under tension. So in this way, the molecule which are present at the surface of any liquid, those are behaving that they are pulled inward. So they want to uh, accommodate smallest possible area. So they minimize their space and minimizes their volume. What are the consequences of surface tension? Liquid surface tend to contract to the smallest possible area. That's why the liquid surface, they are under tension, and therefore they want to contract themselves to the possible smallest possible area. For a given volume, a sphere has minimum surface area. We know that every sphere has a minimum surface area. So drops tend to be spherical. So the liquid drop or air drop, they are in spherical shape. Surface tension helps to explain the shape of the drops. It also explains liquid rise in the capillary tube and the kerosene rise in the wick of lamp. Definition and units of surface tension. Uh, so the definition of this surface tension is the force in dyne acting at right angle on a line 1 centimeter long on the liquid surface. So this is the force. Surface tension is nothing but the force in dyne acting at right angle. It is perpendicular to the liquid surface. So it is at right angle on a line 1 centimeter long. So if we calculate the whatever the force applying from the surface from the upper side or at perpendicular to the liquid surface at one position 1 centimeter line, that is called its surface tension. Its symbol is gamma. Its CGS unit is dyne per centimeter, because whatever the force acting at right angle to a line which is 1 centimeter in length, that's why unit is dyne per centimeter. SI unit is Newton per meter, and this is the relation, that is dyne per centimeter to Newton per meter conversion, that is 1 dyne per centimeter equals to 1 million Newton per meter. There are some different liquids, they are having different surface tension values at 20 degrees centigrade and at 40 degrees centigrade, which is expressed in dyne per centimeter value. So water at 20 degrees centigrade 72.75 dyne per centimeter, while at 40 degrees centigrade exerts a surface tension of 69.56. So by increasing the temperature, the intermolecular force of attraction get decreases, and therefore surface tension also decreases. We can say that. Again, ethyl alcohol, it has less surface tension than water, 22.27 at 20 degree. Again, acetone also has less, 23.7. Toluene also has less. Benzene also has less. The water means in case of organic liquid and water has more surface tension. Means the attractive forces between the water molecule are large as compared to these organic solvents. And by increasing the temperature, surface tension get decreased. We can say that. What are the factors affecting surface tension? There are two main factors which affect the surface tension, that is depend on nature of liquid as well as temperature. So nature of liquid means different liquids have different intermolecular forces of attraction. So there are different gamma values, means surface tension also exert differently. The second factor is temperature. So surface tension increases with increase in temperature. Sorry, surface tension decreases with increase in temperature. We already have seen this table of effect of temperature. So as temperature increases, the kinetic energy of the molecule increases. Therefore, the attractive force between the liquid molecule get decreases. Therefore, at higher temperature, kinetic energy will be higher and weaker effective attraction, and therefore lower gamma value or surface tension values. Capillary action. So when a fine capillary tube is placed vertically in a liquid, the liquid level in the tube may rise or fall. There may be two possibilities. Either the level of the liquid in the capillary may rise or may get fall. So process continues until the upward pull due to surface tension equals the weight of the liquid column. So when we put a capillary in the liquid start rising in the capillary and rises till the weight of the liquid column becomes equal to the upward surface tension of the liquid. Whatever the surface tension exert on the liquid, that equals to the mass of the liquid column. Till that equal to forces, the liquid rises in the capillary. So rise or depression depends on the nature of liquid as well as diameter of the capillary. So it depends on the nature of liquid, whether different liquid have different attractive forces. Therefore, also depends on the capillary radius, that is diameter of the capillary. Meniscus, cohesion and adhesion. So meniscus, what is meant by meniscus? The liquid surface which is always curved. So this curved surface of the liquid is called as meniscus. So liquid surface in the capillary is always curved. It is not a straight. So it may be convex, it may be concave, but it is always curved. So this curved surface, liquid surface, is called a meniscus. So this meniscus may be convex or concave, that depends on the cohesive and adhesive forces. So there are two forces exist. Cohesive forces that exist between the liquid molecules, that are called as cohesive forces. Adhesive force, adhesive means between two different things, that is between liquid and glass. So if adhesive force is greater than cohesive force, what will happen? The liquid molecule will rises weight the glass, means they get attracted toward the glass, and therefore we get liquid weight the glass and meniscus becomes concave. That is water. If we take the water in the capillary, then we will observe like this concave meniscus, because there is a adhesive force is greater than the cohesive force. That is that's why we get concave meniscus. And if cohesive forces are stronger than the adhesive force, means if liquid molecules have maximum force, attractive force, than the liquid and glass, then in that case liquid molecule get come closer and closer and forms a cluster like a heap. So if we observe the mercury present in the uh, thermometer also, then that mercury has a convex meniscus, means the liquid molecule have more force of attraction than the liquid and the glass. Therefore we observe the convex meniscus. So glass not weighted means liquid not migrated toward the glass surface, so they remain close to one another, in close contact with one another liquids. That's why they are not attracted toward the glass surface, and therefore the meniscus is convex. For example, mercury in the glass. Then capillary rise method. Suppose consider a capillary of radius r inserted in a liquid forming a concave meniscus. So liquid rises to a height of h. Consider that if we insert a capillary in the liquid, then the liquid in the get rises to a particular height, that is called h. So upward force due to the surface tension along the contact line balances the downward weight of the liquid column. So this liquid rises till the whatever the surface tension acting on this liquid becomes equal to the weight of the liquid column. Whatever the liquid enters the capillary, that becomes equal to the surface tension acting on the liquid. That's why this liquid get rises, and these two forces, upward force and downward force, get balances. At the time of balance of these two forces, rise of liquid in the capillary get stop. Capillary rise method to determine the surface tension. So we have to determine the surface tension of the liquid. So we can adopt two methods, capillary rise method and drop formation method. So we first see capillary rise method. So in case of capillary rise method, if we insert a capillary inside a uh, liquid, then liquid get rises to a particular height. Suppose h will be the height of this capillary, and r is the radius of this capillary. Suppose r is the radius of this capillary, and theta is the angle. Theta is the angle which is parallel to this um, line, or this edge of this glass. So this is upward force, and theta is also at the same direction, means theta is 0. So vertical component of surface tension will be gamma cos theta, where theta is contact angle. So total upward force along the circumference equals to 2 pi r times gamma cos theta, because this is the 2 pi r circumference of the circle. Therefore the total force, upward force acting along this circumference will be 2 pi r gamma cos theta. But for most of the liquid, theta is equals to 0, nearly equals to 0, and therefore cos 0 is 1. Therefore we may say cos 0 is 1. So upward force equals to 2 pi r gamma, because cos 0 is 1. So 2 pi r gamma into 1, 2 pi r gamma. So upward force acting on this liquid will be 2 pi r gamma. The weight of the liquid column will be pi I r square h dg. Now how these factors can be calculated? So we know that the downward force is equals to a mass into acceleration due to gravity. So this is g is the acceleration due to gravity, and what is the mass of the liquid that rise in the capillary, that can be calculated as a this in place of m we have taken there area of this liquid rise in the capillary having radius r, and h be the height of the liquid rise in the capillary, and d is the density of liquid. So the area into height into the density gives the mass of the liquid rise in the capillary. So mass into acceleration due to gravity gives the downward force, that is the weight of the liquid column. So when upward force become equal to downward force, 2 pi r gamma upward force equals to downward force pi r square h d g. So from this upward force equals to downward force, gamma we have to determine gamma, that is the surface tension acting on the liquid. Therefore gamma equals to h r dg upon 2, where h is the height of the rise, a liquid rise in the capillary in centimeter, r is the radius of the capillary in centimeter, density of liquid is expressed in gram per centimeter cube, and g is the acceleration due to gravity, that is expressed in centimeter per second square, and having standard value, that is 980 or 981, used to calculate gamma from measured HRDG values. Now another method to determine the surface tension is by drop formation method. So in drop formation method we have to use a glass pipette having a bulb and a capillary. This glass pipette is called as stalagnometer. So this glass pipette is having a bulb and having two marking A and B, and below this bulb it has a capillary. Through this capillary, this liquid from this two marking is allowed to uh, pass through this capillary, and whatever the number of drops formed by this liquid, by this volume, total volume V is calculated, and from this number of drops we can calculate the surface tension acting on the liquid. So different liquids have different number of drops for this particular volume, and from this particular number of drops we can determine the surface tension acting on this liquid by measuring the number of drops. So in this drop formation method, in this way drop is formed, and on this drop there are two forces acting: downward force due to mass into acceleration due to gravity of the liquid drop, and upward force is acting due to the surface tension, that is the 2 pi r gamma component. So if liquid is flows slowly through a capillary, drop form at the end. So drop grows until weight mg just balances the upward surface tension force 2 pi r gamma. Then it detaches. So at the time of breaking of this drop from the capillary, there are two forces get balanced, that is upward force 2 pi r gamma and downward force mg. So a stalagnometer is used to count the drop formed from a fixed volume of liquid. So in this way we can count the number of drops. Another method is drop weight method. So we have to determine the weight of the drop. So to determine its surface tension. So what are the steps? Clean and dry the stalagnometer. Then fill with unknown liquid to mark A. Already we have seen the marking A and B. Then collect the known number of drops. Weigh the total mass. Then calculate the mass of one drop of liquid as a M1. Repeat the procedure for reference liquid or known liquid having water. Generally we take water as a reference liquid to get the mass per drop, that is M2. M2 is the mass of drop of water, and M1 is the mass of liquid, unknown liquid. We have to determine that surface tension. So from mg equals to 2 pi r gamma, upward force becomes equal to downward force at the time of breaking of the drop from the capillary. For the radius r, So gamma 1 upon gamma 2 equals to m1 upon m2, or we may say gamma 1, that is the surface tension of the unknown liquid, is equals to m1 upon m2 into gamma 2, that is the surface tension of water gamma 2. So in this way we can determine surface tension of liquid by drop weight method. Then another method is drop number method. So drop number method, we have to determine the number of drops. So for same volume we gives n1 drops for liquid 1 and n2 drops for liquid 2. So n1 and n2 be the number of drops for liquid 1 and 2. Liquid 1 is unknown liquid, having we have to determine its surface tension, and liquid 2 is the reference liquid or known liquid. We know the surface tension of this liquid 2. So volume per drop will be V upon N. Therefore mass per drop equals to V upon N into D. This is the general formula, density equals to mass upon volume. Therefore mass is equals to volume into density. So for to calculate the mass of one drop, we have to determine the number of drops, and V is the volume, total volume. It is same for known as well as unknown liquid, and D is changing. So using gamma 1 upon gamma 2 equals to m1 upon m2 gives gamma 1 is equals to d1 into n2 upon n1 into d2 into gamma 2, that is d1 upon d2 into n2 upon n1. We may say gamma 1 is equals to d1 upon d2, means directly proportional to density, or inversely proportional to the number of drop, means the liquid having a more drop means less surface tension. So gamma 1 is inversely proportional to number of drop and directly proportional to the density of the liquid. So formula is gamma 1 is equals to d1 upon d2 into n2 upon n1 into gamma 2. So this equation is used to find out the surface tension of unknown liquid using a reference, that is water. Then we will see some problems also asked in the exam. So what are the problem on surface tension? Calculate the surface tension of the liquid when a capillary tube of internal diameter, we have to determine surface tension gamma, and the internal diameter of the capillary is given 0.24 millimeter. So we have given diameter of the capillary 0.24 millimeter is deep into a liquid of density 0.79 gram per cm cube. So liquid density D is given 0.79 gram per cm cube. The liquid rises in the capillary to a height of 6.32 centimeter. So height of the liquid rise in capillaries H is 6.32. So we know that the formula for this surface tension is gamma is equals to HRDG upon 2, and what we have given, H is the height of the liquid rise, that is 6.32 centimeter. Density of liquid is given 0.79 gram per cm cube, and diameter of the capillary is given 0.24 millimeter. Convert it to centimeter. So centimeter is equals to 0.024 centimeter divided by 10. So it gives centimeter, millimeter to centimeter conversion. Then diameter we need radius. So radius is nothing but a diameter divided by 2. So radius will be 0.024 divided by 2 means 0.012 centimeter. So gamma is equals to HRDG upon 2. In this way we can put this all these value of height of the capillary 6.32 into radius 0.012 into density 0.79 into G, acceleration due to gravity is taken as 981 centimeter per second square upon 2 gives the surface tension of the liquid. So we can solve this problem in this way. Then summarize. Now I will summarize this topic. So we have seen here surface tension. It is due to the net inward pull experienced on the surface molecules, affect the shape of the drop and capillary rise. Surface tension measurement, we have determined the surface tension by capillary rise method, drop weight method as well as drop number method. So this is all about our topic. So here we can stop here.